Hi everybody, I'm Dimi, and today we are going to use Polytone.
Friends, dear hackers who are in the kitchen, the dinner will be in 1 hour. Please take a seat and listen how you can query interchain data. This is amazing. You can be in the one network and get the data from another network.
Cool, thanks for the introduction. Okay, today we are going to create a very basic smart contract in CosmWasm that performs an interchain query. So we are going to deploy a smart contract on one chain, and we are querying data from another chain, get the result back, and do some logic with it. To do so, we are going to use Polytone. And Polytone Polytone is a set of smart contracts that allows easy cross-chain interactions. To explain better, with Polytone, the idea is that any account can have an account on any other blockchain. And this is done using IBC. And the good news is that Polytone is already deployed on many CosmWasm enabled chain. As of today, it's on 12 chain, including CosmWasm, Neutron, Osmosis, Stargaze, Juno, and so on. So if you learn how to use Polytone, you automatically learn how to do interchain actions within all the supported chains, and the code is basically the same. You can use the same code to interact between Neutron and CosmWasm. You can use the same code to interact between CosmWasm and Juno, and you don't need to rewrite everything every single time. So Polytone is made of 3 modules: node, voice, and proxy. And the idea here is that on chain A, you have the node contract, which take charge of all the interchain actions that you want to submit. And on the remote chain, you have the voice contract, which basically receive that request of interchain action and execute it. This is an example of how our smart contract will work. In this case, we are going to create an interchain counter smart contract, which has an internal counter, but this counter can only be increased if the account who's calling the increment function has some atom staked on a remote chain. So of course, applying this logic when we are working on a monolithic chain is very easy, because you have everything in the state of the blockchain itself, so you can query the staked balance locally. But when you want to query the staked balance on another chain, you need to use interchain queries and IBC. And this is what we are going to do today. We have our interchain counter smart contract with the increment function. When we call the increment function, basically our smart contract is interacting with Polytone, in the specific with the Polytone node contract, which is deployed on chain A. In our example, chain A is the Juno blockchain. So calling increment function create a request for an interchain query of the staked balance of the user who called the increment function. The node contract take this request and save it in the memory. At that point, relayers will take that request and forward it to the voice contract on chain B. The voice contract will receive the request, perform the actual query to the staking module, get some data, and using IBC callbacks is going to send back the data to the node contract on chain A, and the node contract on chain A will send back to our contract. I know it's a little bit complex, maybe I was too fast. I don't know if you have any questions for now.
How long does the process take?
How long does the process take? It really depends on block time on both chains, because basically you need one transaction to call the increment function, and in that transaction, since we have sub-messages, the interaction with node contract is already in that transaction. So let's say on Juno you have a 3 seconds block time, so it's 3 seconds for that transaction. And then you need to wait relayers to pick up your interchain query request and send to CosmWasm. CosmWasm has a block time of 6 to 7 seconds, so it takes at least another 6 seconds to send the request on CosmWasm. Then you need to wait again the relayers to pick up the result of the query on CosmWasm and send back to Juno, so it's another 3 seconds. So it could take like 15 to 20 seconds. And of course, from a user experience perspective, it's not ideal. But the way we are going to implement this for the user, it's transparent because they see only the increment transaction. They don't get any, I mean, this is just an example. They don't get any feedback. And that after a while, the state of the smart contract is updated. Okay. Yeah, I prepared a GitHub repository if you want to check it out, where basically I'm going through every single step on how to set up a local environment. So we are going to create 2 local blockchains, one for Juno, one for CosmWasm, which are local testnets, so you have your fake tokens, you can play with it. And we are also going to spin up a relayer between the 2 blockchains. And in the guide, I also explain how to deploy all the smart contracts needed, so the node and the voice of Polytone. And finally, we are also going to see how to actually implement Polytone in our own smart contract. Okay. I'll open it.
Can you zoom?
Yeah. Actually. Is it okay? Better? So in the, can I go on? Someone wants to open GitHub. You ready? 1 second. Okay. Well, I can explain in the meanwhile. So in the first file, it's a basic development environment setup. Since this is touching many pieces of Cosmos, we actually need a lot of dependencies. Because we need Golang to build the relayer, because binaries for Mac are not provided, so we need to build our own. We need Rust and Cargo to actually build this smart contract. We need Docker to run our own chains locally. And we also need the binary for local interchain, because we don't want to mess with Dockerfile ourselves. So we are going to use that utility to spin up the blockchains. And finally, we need the binary of Hermes to handle the relaying. And I'm not going in depth on how to install every single piece of this, but in the documentation you have all the links that you can follow to set up everything. For the chain setup, so to spin up local chains, I recommend to use local interchain, which is a product made by Strangelove Ventures, and it allows, based on a configuration file, to create any chain in Cosmos locally, with some also custom parameters. For example, you can override governance parameters if you need to do proposals. You can create keys. You can give yourself any token you want. and it's quite easy because it's just a big JSON file where you have an array of chains that you want to spin up. In this case, for example, we have the first one, which is Juno, and you need to specify the Docker image, and then a bunch of configuration to create the chain. And of course, don't try to use this mnemonic because it's my own mnemonic. Please don't steal my mnemonic.
Too late.
So bad. And the second chain we are going to spin up is a replica of CosmWasm. And since in Cosmos we love to name things in a very complex way that nobody remembers, the binary of CosmWasm is actually called Gaia, and so Gaia is a local version of CosmWasm. And the same, we have a bunch of configuration, keys, and so on. And if we create this JSON file and we have the local interchain binary installed in our computer, we can simply run this command, and in Docker the two blockchains will be spin up. And I can try in production. Let's see if it works. Actually, I was already running it, but I stopped using Ctrl+C. And you can see in my Docker desktop that my two old blockchains are now killed. And if I run again the command, I can spin up again the two blockchains. And yes, you will see some crazy stuff because they are running transactions. But after a while, the two blockchains will be up and running. And actually, local interchain comes also with some APIs. So if you want to automate it, for example, to do some end-to-end test, you can use it. I'm not going in depth to that as well, but there is tons of documentation on how to use it. So after we run our two blockchains, we can actually query. For example, we can get the RPC endpoints. The ports is in the file. For example, if we go to localhost, at this port we get an RPC endpoint for one of our two chains. And if we go to the other port, we get the other blockchain. So this is the first step. And now that we have two blockchains running, we can start playing around and trying to deploy the smart contracts. I can continue on step 3. So as next step, we want to actually deploy Polytone. Of course, in a production environment, as I was saying, Polytone is already deployed, so you don't need to deploy your own contract of Polytone. There is already Polytone production instances deployed all around Cosmos, and so you can just get the addresses. And I have put here a link to a JSON file, and this is coming directly from the creators of Polytone, DAO. And here you can see basically all the smart contract addresses of all the Polytone instances around. So for example, if you want to use Polytone between CosmWasm and Juno, you just check for CosmWasm, and under CosmWasm you see as a subchain Juno, and you have the contract address for the node and the voice contract. And you can use these in production. It's quite convenient, because in this way you don't need to bother about relaying and IBC connection. You just put the production Polytone addresses and you're done. But in this case, since we are local, we need to deploy the contracts, and we need also to run the relay here, because everything is in our computer and no one wants to help us. Okay, here I skip. There is a little bit of configuration for the local command line, and I also pasted a small explainer of all the flags of the Docker commands. because maybe someone is not that familiar with Docker, and there are many flags there. Okay. So the first thing to do, we want to deploy our node smart contract on the Juno blockchain. So the chain A, the chain that wants to perform the query, needs to have an instance of the Polytone smart contract. So we can, in a new terminal, we can deploy the smart contract. In this case, I'm using the standard Juno command line, but it's basically the same for every single CosmWasm chain that it's using Cosmos SDK. So you use TX for transaction, and then the module name, so Wasm module, and then the transaction type that you want to execute, in this case store, and I'm passing as an argument the Wasm compiled version of Polytone, which is included in the repository I gave you, but if you want newer version, because maybe you are doing it in a future time, you will find the binaries, of course, in the Polytone GitHub repository. So with this transaction, I stored the code of Polytone on chain A, which is Juno. Sorry. Yeah. Sorry.
A little bit to the right of terminal. Cut it off. There we go.
Okay. And the second thing I need to deploy is the voice contract on the remote chain, so on my CosmosHub clone chain, both so I need to deploy both the voice and the proxy. Voice and proxy. So at this point, if I do a query, I can check that my chains have all the code ID correctly stored. So with this command, query wasm list code, I can check all the code IDs that are currently deployed on my local blockchains. And in this case, I'm querying Gaia, so I'm querying my CosmosHub clone. And I have code ID 1, which is the voice, and code ID 2, which is the proxy. And I know the proxy, I haven't explained what is it, but it's because we are not going to use it. But it's needed for a Polytone deployment, even if we are not using it. After we have the code stored in the blockchain, we can actually instantiate the smart contract. So the way CosmWasm works is that you first deploy your smart contract code, and then this code can be instantiated many times with different parameters by anyone, actually. And this is used to save storage in the blockchain. We don't need to deploy 200 times the same code. If the code is already there, we can reuse it. So with this command, I'm going to instantiate on Juno the code ID 1 with some parameters. This is the maximum block gas that Polytone will use. And once done, I can do the same for the voice contract and the voice contract. So on Gaia, with Gaia D, I can do the same instantiate function, and for the voice contract, I need to specify the proxy code ID, which in this case is 2, and the block max gas again. At this point, I can do another query to check the smart contract addresses that I just instantiated, and I can do, for example, this. So with this command, I'm asking the WASM module to give me all the contracts instantiated that are using the code ID 1. So since I'm doing this on Gaia the code ID 1 is the voice contract. So this will be the address of our Polytone voice contract. And if I do the same but on Juno, I'm going to get the note contract. So this is the address of the node contract for Juno. Now that we have Polytone set up, we can configure the relayer. So as I was saying, since we are local, we need to configure a relayer, an IBC relayer between our two local blockchains. And we are going to use Hermes for it. There are many relayer software. Hermes is one of the most common, and it already supports Polytone with a simple flag. So I think it's the easiest relayer to use in this case. Again, I'm skipping all the keys adding because I already did in my computer. But if you are doing it, you will have to add your own keys. But the first command that we need to do is to create an IBC connection between my local Juno blockchain and my local CosmWasm blockchain. And again, I can do it in a terminal. This is small, okay, I'll do it here. Okay, if I run that command, Hermes create connection. Hermes will do all the blockchain transactions on each side to open an IBC connection. After the IBC connection will be open, we will need to create also an IBC channel between my Polytone node contract on chain A and my Polytone voice contract on chain B. And this is because the communication on IBC happens on channels and on ports. So as you can see, my old command of create connection is successful. So now I can create a channel. And it should take a while, but it should work. And meanwhile it's creating, we can move on. And I'm going to skip this file, which is an example using some Polytone example contracts, and I will skip directly to our CosmWasm smart contract, which I think is more interesting. So we can jump to the smart contract code, and in the repository is inside this folder, which is Interchain counter. And for those who are not familiar with CosmWasm, on CosmWasm smart contracts, we have all the logic of the smart contract inside the SRC folder. And inside the SRC folder, usually we have a few default files. We have one important one, which is msg.rs, which includes all the messages that the smart contracts implements. So for example, in this case, we have the increment message. We have a reset message to change the count value to an arbitrary one. And we have this callback message. This callback message is actually the Polytone callback message. It's the function that will take the query result and do some logic with it. Showing in the code, I can show you. So the first function that our smart contract will call is the instantiate function. In the instantiate function, we are going to save the state of the smart contract. We are going to set the count to 0, actually to what is being provided in the message. And we are also saving in the state of the smart contract the node address of the Polytone node smart contract. This is because we need to know the Polytone node address in our own contract so that we can then call a sub-message to it to do the interchain query. So in the instantiate function, we are just setting some basic state. After it, we have the execute function with all the different execute message that I was speaking before. The one that are of our interest is the increment message and the callback message. So in the increment function, even if it's called increment, we don't actually want to increment the counter. Why? Because this increment function can be called by any address, but we don't know yet if that address is an atom staker. As I said before, we want the increment counter to only increment if who is calling it is an atom staker. But we are on Juno, so we don't know if that user is an atom staker. To know it, we need to do an interchain query. So in this case, I was trying to explain the increment function. So as I said, during the increment, we don't really want to increment, but we just want to trigger an interchain query to ask if our user has some staked atom balance. So the first thing that we need to do is convert the Juno address to a Cosmos address. And for those who doesn't know, on Cosmos, all addresses are the same public key. So you just need to convert the address from a Juno prefix to a Cosmos prefix. And since are using the same public key, you can basically derive the Cosmos address of a user knowing any other Cosmos blockchain address. And so the first thing that we need to do is this. It's just an address conversion. After that, we need to prepare the Polytone execute message that we will include as a sub-message of our smart contract. And in this case, we are using the query execute message of Polytone. The query execute message of Polytone takes two parameters. The first parameter is messages, which is the Cosmos modules messages that you want to query. So in this case is the staking module, and we want to query for all delegation for this specific address. And in the callback, we are configuring how do we want to get the data back from Polytone. So in this case, we are setting the receiver of the callback to be this same address. And the message, it's not very important in this case. It's used more for so for bigger smart contracts where you need to differentiate different messages. So in this case, I just put test and it doesn't matter. And then we can also specify a timeout for the transaction itself. So if our transaction is not relayed within 5 minutes, it gets discarded and the result of it is ignored. In this piece, we are setting up the sub message, and then we are returning the response to the user. So in this case, we are just triggering an interchain query. So what will happen is that we request the interchain query, relayers pick it up, send it to the voice contract on Cosmos Hub, get the result, and will send back to us. And will send back to us in our callback function. In the callback function is where we are going to do the increment. Again, this is just a test smart contract. Of course, implementing logic inside the callback message is not that good quality code, but it's just an example. So in this case, we need to verify that who is calling the callback is actually the node contract. Otherwise, anyone can just call the callback message with arbitrary data, and we don't want it. And as soon as we get the callback, we can check the result and we check the result. We need to deserialize from JSON the delegation response, and then we can check that the amount is greater than 0. Again, this is not production ready code, it's really thrown there in 5 minutes, so I'm quite ashamed for it, but it works. And as soon the check is done, the state is updated and count increases by 1. And this is all the logic that we need, all the code that we need to write if we are going to use Polytone and interchain queries. It's literally, how many lines? 10 lines and, I don't know, 50 lines. And you do an interchain query if you already have Polytone deployed, which is most of the cases. So it's very, very simple. I don't know if I have time. I think yes. But I can demonstrate this and see that in production doesn't work. Okay, so we have our 2 blockchains spin up. We need to deploy our own smart contract, which of course I already built. So I'm going to deploy it on Juno, which is the chain A. Okay, the smart contract is deployed. After it's deployed, I want to instantiate my contract. And as you can see, I'm setting the initial count to 0 and the node address to the address that we instantiated before. And if everything is successful, I should be able to query my contract. So, Juno D. Okay, yeah, I have the contract address. So this is the address which is deployed, and I can query the count using this other transaction. I can query the state of my smart contract, and I can query the count value. The count value is 0. Okay, now if I want to increase it, I first need an account with staked atoms. So I can stake some atoms with my account 1. But first I need to check what is the validator address. Okay, this is the validator address. I can copy paste my command. And my amount. Okay, now I have 2 accounts on CosmWasm blockchain. I have account 1, which is delegating 10 microatom, and account 2, which is not delegating any token. So in theory, if I use account 1 on Juno and I try to increment, the smart contract will increment the counter. If I instead use account 2, which is not a delegator, the counter should not increase. So simple. Let's try doing from account 1. And we got an error because I have pasted the wrong smart contract address. Let's pick the correct one from here. Okay, so now the interchain query is scheduled. And to flush IBC transaction quickly, I'm going to restart Hermes, which is the relayer. And this will pick up my pending transactions and do all the IBC relaying stuff. And you can see it has been already done because we see this transaction hash in the log. So now if I query the get count again, I should see that it's 1. So in this case, the interchain query worked. And if I do the same from account 2, even if the transaction is confirmed, and I will restart Hermes again, and I should see again some IPC relaying, and I already see some transactions. Yeah. Sorry if it's too small. So everything has been relayed, And so we can query again the get count, and it's still 1. So in theory, our logic is working. And that's it. Yeah, on GitHub you find all the code. I know it's quite complex and I went very fast, but yeah, it's not something that you do in 10 minutes. Thank you.
Do we have any questions? Here we go in the front.
Thank you for this wonderful presentation. I work at Abstract, and at Abstract we use Polytone extensively, so I get to use Polytone every day, which is a joy, so thank you for that. My question was on those queries. So for the hackathon this weekend, this is a Neutron hackathon, and Neutron has an Interchain query module, and so my question is, why should we use Polytone queries instead of Neutron queries?
So I don't know in specific Neutron, but I think the main difference is that Polytone is async and Neutron is sync, or not?
So on Neutron it's also async,
Okay.
but they have relayers which do the query for you, so you don't have to. It's also an execution, but there is no execution on chain B. It's just
Okay.
a relayer that takes the raw data and puts it in your contract.
Yeah, so I'm not that familiar with the Interchain queries module on Neutron, but I think the advantage of Polytone is that it's already deployed on many chains, so you can reuse the same code on Juno, Neutron, CosmWasm, Osmosis. You don't need to rewrite anything except the node address, and since it's already deployed, also relayers are already deployed, so you don't need to relay the stuff yourself. There are already many relayers doing everything. So I don't know the advantages of each one, but I think it's a considerable solution also, Polytone.
Any more questions? One more round of applause.
Thank you.